Hi, today we'll be looking at minimum cost for tickets. This is a medium problem. You have planned some train traveling in 1 year in advance, and the days of the year in which you will travel are given as an integer array days. Each day is an integer from 1 to 365. Train tickets are sold in three different ways. A 1 day pass is sold for costs of $0. A 7 day pass is sold for costs of $1. A 30-day pass is sold for costs of $2. The passes allow that many days of consecutive travel. For example, if we get a 7 day pass on day 2, we can travel for 7 days, 2, 3, 4, 5, 6, 7, and 8. Return the minimum number of dollars that you need to travel every day in the given list of days. So, how do you think about this? You have some days, you have some costs for buying a certain ticket on a certain day, and you need to find the minimum number of dollars you need to travel every day in the given list of days. So, what does this tell you? That on every day, you need to try out either a 1 day pass, a 7 day pass, or a 30-day pass, see what happens, and then calculate, like, try out all of these three uh, choices for every single day, and then calculate the minimum of every time. So that's like you need to try out always. And when you think of trying out always, it comes to recursion. So for each of this in the array, you'll have like three choices. So that's going to be a 3 square in time complexity, which is a lot. So let's see what's going on. So when I solved this, it's like I have taken a min cost tickets function, and inside that I have my recursive function which takes in an index and max reach. I felt like max reach is something we need to know. We need to know that we are able to, reach. Otherwise, we cannot move from this index onwards. Like we'll have to not move anymore. So let's say we start from the 0, 0. So basically, your index is 0, your max reach is 0. If your This is the main part. So if like at every index, if the days of I, what does days of I mean again? One. So basically you want to travel every day on this given list of days. So if days of I that you want to be traveling on day 1 is greater than equal to max reach, that is you can reach like this, then you need a ticket. So ticket 1 will be costs of the 0, and then f of I plus 1 and days of I plus 1, and then I plus, and this will again move to the next index in the thing, and then day plus 7, and this will be day plus 30. So that's it, and you get the minimum of all of this. And if you can't buy, like if you don't buy anything, then this will be f of I plus 1, and comma, the max reach stays the same, it does not change. And the answer will be the minimum of answer, and this. So what is exactly happening here? At every point, what you need to check is your days of I greater than max reach? That is, max reach is less than days of I. So in that case, you need to buy a ticket. That's exactly where you need to buy a ticket. So you try choosing all of these tickets and seeing recursively what happens. Otherwise, you don't really even need to buy a ticket. You can just keep going with that max reach, and yep. So that's it. This works like this one. There's another, so you have a bunch of overlapping subproblems, and that's exactly where memoization comes in, and then that's how you solve the problem. That's it, thank you. But the most important thing in this problem, I feel like, is this thing. So it's either like thinking about when do you need to buy a ticket? You don't need to buy a ticket if you are already able to reach a certain index. Like if you're able to reach that index with the tickets that you bought before, you don't need to buy anything, just keep going. But if you're like if you've just reached, like if your max reach is over, and like your days of I is greater than equal to your max reach, then you need to buy a ticket now. You need to use some of your money out there, and that's the main thing I feel. It's like a if or else. It's not like a max of these two. It's always an if or else. That's how you get the minimum. And if we reach the end index, then we return a zero, and that's like the least cost. And if we go over the last index, then we return an infinite, like int max, so that's never like minimum. So we don't consider that option. So yep, that's it. Thank you.